A very good afternoon to you all students. How are you all students? You all are fine. So I'm hoping that you all are fine and you all are staying at your homes. Okay. So students, let's begin our today's discussion. Okay. So students, here in front of you is a sheet of paper. You can see it, right? It is a sheet of paper. So it's an A4 size paper. Okay. So students, now if I ask you what is the shape of this paper, then what will you tell? If I ask you what is the shape of this paper, what will you tell? Of course you will tell the shape as rectangle, right? It is a rectangular sheet of paper. Okay, and yes, it's the correct answer. Okay, but now consider similar kind of A4 size papers. Okay, there are a lot of A4 size paper of this same size. Okay, and what I'm going to do is that I'm going to pile those papers one over another. I am going to pile these papers one over another. I am going to make a stack of such papers. Okay, I'm going to make a stack of such papers, something just like this. See? Okay, so now students, if I ask you, is it still a rectangle? If I ask you about the shape, will you call it a rectangle now? Definitely not, right? Why you will not call it as a rectangle? Because here another dimension has been added here. See, initially when a single sheet of paper was there, only two dimensions were there. What were those two dimensions? They were the length as well as the breadth. Okay, where you will only be able to calculate the length and breadth of a single sheet of paper. Okay, right? But in this case, here along with length and breadth, another dimension has been added, and that is the height of the stack, right? It is the height. So the height factor has been added here. Okay, so basically, what is the difference between the previous picture and this picture? What is basically the difference between a single sheet of paper and a stack of such paper is that earlier there were two dimensions, right? But here another dimension has been added, right? And it is now a three-dimensional object. Okay students, it is now a three-dimensional object. So what is the name of this object? Try to recall students, you have learned it before. What is the name of this object? It is a cuboid, right? What is it? It is a cuboid, right? We cannot call it as rectangle now, right? It is a cuboid. So students, this is basically a difference between a three-dimensional and a two-dimensional object. Okay, so now look at this picture. So you must be familiar with this picture, right? Have you ever played this game? I probably think that yes, you have played this game, right? So now students, if I ask you about the shape of this object, what will you tell? What is the shape of this object? Yes, the shape of the object is cube, right? The shape of this particular object is cube, right? So students, we have learned about cuboids and cubes in our previous classes, right? Now we'll again use this same concept. Okay, so this is a cube. Similarly, this object, it is also a similar kind of object, right? It is also a three-dimensional object, but will you call it as a cube? Is it a cube? No, it is not a cube. It is a cuboid, right? It is a cuboid. But students, how are we being able to differentiate between a cube and a cuboid? What are the factors that we have to consider in recognizing a cube and a cuboid? Okay, so to understand this, we have to look at the definition of a cube. Okay, so let's see what a definition of a cube says. Okay, see, so the definition says that a cube is a three-dimensional figure with 6 congruent square faces. Okay, there are a total of 6 congruent square faces, right? And most importantly, opposite faces are on parallel planes, whereas intersecting faces are on perpendicular planes, right? So students, what you have understood from this? See, in the picture given below, see, there are total of 6 squares. Okay, there are total of 6 square units, and these 6 square units combine together to form the cube, which is in your left hand side, right? So what we can tell is that 6 similar or 6 same squares combine together to form a cube, right? So a cube is made up of only squares. Okay, but now if I talk about cuboid, so what is the basic difference between a cube and a cuboid? How a cuboid is different from a cube? Okay, so to contrast among these two, let's look at our next slide. Okay, see, so we'll now look at the properties of a cube and cuboids. Okay, so on looking the properties of both the cube and cuboids and comparing them, we'll be able to distinguish between a cube and a cuboid. Fine, so let's start. So both cube and cuboid has 8 vertices, right? And also they have 12 edges. Okay, these are similar in both the cases, but in case of cube, all the edges are of equal length. In case of cube, all the edges are of equal length. Why is it so? Because a cube is made up of squares, and we know that a square has 4 equal sides, right? A square has 4 equal sides, and hence a cube will have all the edges equal. But on the other hand, see, in case of cuboid, we will not get all the edges of equal length. Why we will not get all the edges of equal length? Because a cuboid is made of what? A cuboid is made up of rectangles, right? And we know that rectangles do not have all the 4 sides equal. Do rectangles have 4 sides equal? No, rectangles only have their opposite sides as equal. Their adjacent sides are not equal, and hence a cuboid will have a different edges, right? And then both cube and cuboids have 6 faces. Okay, right? And cube will have square faces, whereas cuboid will have rectangular faces. Okay, so this was basically the difference between a cube and a cuboid. Okay students, so now what actually I am going to discuss today is the term surface area. Okay, the term is surface area. Okay, so students, you have learned about area, right, in your previous class, but here along with area the term surface has been added. The term surface has been added. So can you find the difference between the term area and surface area? Do you have any idea about it? See students, we use the term area for two-dimensional objects. For two-dimensional objects such as squares, rectangles, triangles, circles, right? We use the term area for those objects. But for three-dimensional objects, we will use the term surface area, right? Not only area, we will use the term surface area. Okay, what the definition of surface area tells? So the surface area of a solid object is the measure of the total area that the surface of the object occupies, right? That means the surface area of a solid is the measure of the total area, right, that the solid occupies, right? So here we are going to calculate the entire total area, right? Not only the area that is covered by the base. Okay, we are going to calculate the total area. Okay, so let's first begin with cuboid. Okay, we'll now try to find the surface area of a cuboid. Okay students, so in order to find the surface area of a cuboid, okay, we have to calculate the total area of all the 6 faces, right? We have to calculate the area of each face of a cuboid. right? And we know a cuboid has a total of 6 faces, right? So see here in this picture, the two sides, okay, I mean order to two rectangles which are in blue, okay, which are in blue will have the same area. Okay, so why these two rectangles will have the same area? Because they are on the opposite planes. Okay, they are on the opposite planes of a cuboid, and we know that, okay, and we know that the side to the opposite planes on a cuboid have equal area, right? So these two rectangles which are colored in blue will have the same area. Okay, similarly again, these two rectangles which are colored in purple, okay, which are colored in purple will also have the same area, right? The front and the back rectangles will again also have the same area. Okay, now there is another two pairs of rectangles remaining, that is the front and the back side of the rectangle. Okay, that means the rectangles which are painted in green, right? Similarly these two rectangles will also have the same area, right? The rectangles in the front will have the same area as the rectangle in the back, right? So students, what we have done is that we have grouped all the 6 rectangles, okay, into a group of 3, right? We have found total 3 pairs of rectangles having different area, right? We have found total 3 pairs of rectangles having different area, right? Now what we are going to do is we are going to add them all. We are going to add them all to find the total area, total surface area of this entire cuboid. Okay, so see students, here now in order to find the total surface area, we are going to add those rectangles. See the blue rectangles, okay, so the blue rectangles will have the dimensions of what will be the dimensions of the blue rectangle? So from the figure you can see that the dimensions of the blue rectangle will be length into width, right? And again the dimensions of the violet rectangles will be height into width, right? And similarly the dimensions of the green rectangle will be what? The dimensions of the green rectangle will be what? Length into height, right? You can visualize from the picture given here, right? You can visualize here, right? So we have got the dimensions of all the 3 pairs of rectangles, right? Okay, but we know that there is also another blue rectangle at the bottom, right? Like the rectangle in the top, there is also another blue rectangle at the bottom having the same area, right? So hence we have multiplied with 2. See, this is why we have multiplied the dimension with 2 so that we can calculate the total area of those 2 rectangles, right? So similarly there is also another violet rectangle, right, in the other side, right? And also there will be another green rectangle on the back side. So hence we have multiplied each type of rectangles with 2. Okay, we have multiplied with the dimensions of 2. Okay, and then see, we have finally calculated the area of all the 6 sides of rectangle. See what we have done just now, we have finally calculated the total area of all the 6 sides. So hence on adding this up, we will get the formula for calculating the surface area of a cuboid. See, so finally what the surface area of a cuboid becomes? It is 2 into length into width plus 2 into height into width plus 2 into length into height, right? So on adding these 3, we are getting the surface area of this particular cuboid. See students, how simple it is, right? We just have derived the formula for calculating the surface area of a cuboid, right? So what is the formula now? The formula is 2 into length into width plus 2 into height into width plus 2 into length into height, right? So students, now on knowing the values of length, height and width, right, on knowing the values of these 3 dimensions, we can easily find the surface area of this cuboid, We can easily find just on putting the values. We can find. We just have to calculate and then we'll get the surface area, right? So students, let's put the values of length, height and width here. So here students, what will be the length here? So here the length is 8 centimeter, right? And what is the width here? The width here is 5 centimeter, right? And similarly the height will be 7 centimeter. Okay, we have got the 3 dimensions here, that is the length, width and height, right? So on substituting the values, we are getting the surface area. See, now the area of the top rectangle will be what? 8 into 5. Similarly we got 40. Similarly the area of the violet rectangle will be what? 7 into 5, right? Which is 35. Again the area of the green rectangle will be what? 7 into 8, right? Which is 56. So what we just got? The area of all these 3 rectangles. Now what we have to do? We just have to multiply with 2. Why we have to multiply with 2? As I have mentioned before, there are 2 such rectangles, right? We are considering a pair. So we'll multiply with 2. And on doing this, see what the value becomes. It is 80 plus 70 plus 112, right? And adding this up, we'll get the total surface area, that is 262 centimeter square, right? So we finally found the surface area of this cuboid having dimensions of 8 into 5 into 7 centimeter, right? And what is the surface area of this cuboid? The surface area is 262 centimeter square, right? So students, this is how we can calculate the surface area of a particular cuboid, okay, given the dimensions. So now students, we have found the formula for calculating surface area of a cuboid, right? But there is also another shape, another 3-dimensional shape which I have mentioned before. What is that shape? That shape is cube, right? So similarly we will also find the formula for calculating the surface area of a cube. Okay, so students, now we are going to look at the cube. Okay, so say students, so first of all, what we know is that from the properties of a cube, what we know, that all the edges of a cube are equal. Each and every edge of a cube have equal length, right? There are total of 12 edges, right? And we will use this property to derive the formula. Simple. Okay, so since a cube is made up of a 6 square, a total of 6 square, right? Hence if we can find the area of a particular square and then multiply the area with 6, we'll get the total surface area of that particular cuboid. Yes or no? We'll get or not? If we multiply the area of any particular square of the cube and then multiply with 6, then we'll get the total area. So now what will be the area of a particular side of a cube? It will be side into side. That is, if we consider that length will be x, okay, let's say the length will be x, then what will be the area? It is x into x, that is x square, right? So finally, what is the area of a single side of a cube? That is x square. And now there are a total of 6 such sides that makes up the cube, right? So we simply have to multiply by 6. Okay, we simply have to multiply by 6 and then we will get the total surface area of this particular cube. Okay, we'll get the total surface area of this particular cube. So students, finally we derived the formula for calculating the total surface area of a cube, that is 6x square. Yes or no? So on knowing the value of x, we can calculate the total surface area. Okay students, so students, here is a problem. So it is a cube, right? And we have to find the surface area here. Okay, so from the picture you can clearly find the value of x. What is the value of x? The value of x is here 5 centimeter, right? The value of x is 5 centimeter, and we know the formula. We just have derived the formula, that is surface area is 6 into x into square, right? 6x square, right? So On substituting the value of x here, what we got? 6 into 5 square. And on simplifying, what we got? 6 into 25, that is 150 centimeter square, right? We got the total surface area of this particular cube as 150 centimeter square, right? So see students, it's very simple, right? If you know the formula, if you know the values, okay, you just have to put in the value in the formula and then just try to solve it, okay, and you will get the surface area, right? See how simple is that. So students, today what we have discussed is that we discussed about three-dimensional shapes initially, right? How it is different from a two-dimensional shape, right? We discussed. So a three-dimensional shape will have a total of 3 dimensions, right? An extra dimension gets added, right? And we have discussed about what? Cubes and cuboid, right? And we also derived the surface formula for calculating the surface area of a cube as well as cuboid, right? We have derived the surface formula of surface area of cube and also cuboid, right? So students, remember those formulas, okay? You must have to remember those formulas, and then only you can able to solve problems, okay students? So here are some examples, okay? I mean, here are some questions, okay? So here there are cubes as well as cuboids here, so you have to find the appropriate formula, okay, and then you have to find the surface area of this, okay? In the next class I will check this, okay? You have to do this, okay? So students, this was what I wanted to teach you today, that is the surface area, okay? So I think I have made myself clear, okay, in understanding the concepts of surface area of cube and cuboid, okay? So students, do this at your home, and from the next class we'll discuss further, okay? So students, thank you for being with me, and